In a canyon on the Nevada-Arizona border, engineers once ran a refrigeration system through the inside of a dam. Not around it, through it. Steel pipe buried in solid concrete, pumping ice water through a wall built to hold back the Colorado River. In the middle of a desert, at the bottom of the Great Depression. To understand why, rewind to the drafting tables. To one number. According to the Bureau of Reclamation, if Hoover Dam's concrete had been poured as a single block, it would have gotten so hot that it would have taken 125 years to cool back down to the temperature of the air around it. Let that land. Poured in the 1930s, that concrete would still be cooling right now, with decades left on the clock. This is the story of how they stole that century. It runs through a construction method the Bureau itself calls a giant Lego set, an ice factory running around the clock in the desert, and 582 miles of pipe they sealed inside the dam on purpose and never took out. And it ends with the reason the most famous legend about this place, the bodies supposedly buried in the concrete, cannot be true. But none of that makes sense until you answer a question most visitors never think to ask. Concrete is rock, water, and powder. Why does it get hot? What is there to burn? Here's the thing. Almost everyone gets wrong about concrete. It doesn't dry. Drying is what a puddle does. Concrete cures. The water and the cement lock together in a chemical reaction, and like a lot of chemical reactions, this one gives off heat. Every sidewalk you've ever walked on ran warm while it hardened. You never noticed, because a sidewalk is thin. The heat leaks out into the air in hours and nobody cares. Now scale that sidewalk up into a wall of concrete filling a canyon. Heat doesn't leak out of a mass like that, because concrete is a terrible conductor. The outer layers act as a blanket wrapped around the core. The inside of the pore just keeps reacting and keeps heating, with nowhere for the energy to go. That's what the 125-year figure actually measures. Not how long the dam takes to harden, but how long a single monolithic pore would need to bleed its own chemical heat back out through itself. And a mass that cools over a century doesn't cool politely. The outside shrinks while the inside stays hot, and the structure fights itself from within. That failure story is its own episode. This one is about what the engineers stared at on paper, a schedule measured in years, and a material demanding a century. Physics doesn't negotiate, so they tried to trick it instead. Because here are two sentences that cannot both be true. You cannot pour this dam as one block. And, when you're finished, it must behave as one block. The drawing that resolved that contradiction looks less like a dam and more like a toy. Instead of one pour, Hoover Dam went up as vertical columns of individual blocks, stacked and interlocked. Near the upstream face, a block's footprint ran roughly 60 feet square. Toward the downstream face, the columns slimmed to about 25 feet square. Each column rose in shallow pours, one modest lift at a time, so no single pour ever held enough fresh concrete to cook itself. Picture the top of the dam mid-construction. Not a smooth surface, but a skyline of concrete towers at different heights, and on top of every one of them, men. Crews moving buckets, spreading each shallow lift, walking every square foot of fresh concrete as it went down. The pour wasn't an event. It was a place people worked day after day, on foot. And the columns weren't just stacked side by side and hoped into place. Adjacent columns locked together through vertical and horizontal keys cast into their faces, knobs and sockets gripping each other so the finished columns behave as a single mass. The Bureau of Reclamation's own suggestion for picturing it: think giant Lego set. Small blocks solve part of the heat problem on their own. A shallow lift has far more surface for its size, so each pour sheds heat the way a sidewalk does instead of the way a mountain would, but sheds heat to where? This is Black Canyon. In summer, the air itself is an oven. Waiting for desert air to pull the heat out of every one of those blocks, one by one, was still a schedule the project could not survive. The blocks bought them a fighting chance. What they needed next was something the desert does not have. They needed cold, industrial quantities of it, on demand, in one of the hottest places on the continent. So they did the only thing left. They manufactured winter. On site, the builders ran a refrigeration plant capable of producing 1,000 tons of ice every 24 hours. 1,000 tons, every day, in the desert. Not to chill anything for the workers, to chill the dam itself. Here's how the cold got inside. Before each new lift of concrete went down, crews laid steel pipe across the top of the block, pipe about an inch across, roughly the thickness of a garden hose. Then they poured the next lift right over it, entombing the pipe forever. Ice-cold water from the plant circulated through those loops, flowing through the heart of every block, picking up the chemical heat of the curing concrete and carrying it out of the dam. The concrete didn't have to wait for its heat to crawl out through all that stone. The heat got a ride. Do this block after block, lift after lift, column after column, and the plumbing adds up to something absurd. More than 582 miles of 1-inch steel pipe embedded in the dam. It is all still in there, every mile of it. You cannot pull pipe out of cured concrete, and they never intended to. Hoover Dam isn't a wall of concrete with a cooling system. It's a cooling system that became a wall. But hold on to the picture from the top of those columns, because it matters for something else entirely. Shallow pours, pipe crews, bucket crews, finishers. Every lift of concrete in this dam went down under the eyes and boots of working men, and the work was genuinely dangerous, which is exactly where the darkest story about Hoover Dam comes from. And it's where that story falls apart. The Bureau of Reclamation's official count is 96 men killed on the project. 96 is the real number, and it deserves to be said plainly, because the legend that grew around it doesn't honor those men. It erases how they actually died. The legend says some of them are still in the dam, that a man who fell into wet concrete was simply poured over because the schedule mattered more than the body. You now know enough to take that legend apart yourself. Think about what you've seen in this episode. The pours were shallow lifts spread across the tops of blocks, surfaces crawling with workers placing pipe, spreading concrete, finishing every square foot by hand. There was no deep pool of concrete to vanish into, and no unwatched moment to vanish in. And there's a harder reason, the engineering one. A body in that pour isn't a burial, it's a flaw. Sealed in concrete, a body doesn't become part of the dam. It creates a void, a weak point, in a project whose entire cooling and block system existed to make the mass sound and monolithic. The men running this pour built an ice factory and threaded hundreds of miles of pipe to control what happened inside every block. They were not going to leave a hole in one. The method protected the dam from the legend. The open question was whether it had protected the dam from the clock. All those miles of pipe, all that ice, existed to make one specific day arrive early. The day the water in the pipes could finally stop moving. The day the dam was cold. And when that day came, it would drop a strange decision into one room. A decision we'll get to. So, did the gamble work? Per the Bureau of Reclamation's record, the cooling of Hoover Dam was completed in March 1935. Read that date against the number this episode opened with. Physics had quoted them 125 years, a cooling process that would have outlived the engineers, their children, and their grandchildren. The blocks, the ice plant, and the 582 miles of pipe delivered a cold dam while the project itself was still underway. They didn't wait out the century. They ran it through a machine, and then they shut the machine off. Which brings us to that decision. Someone, in March 1935, had to look at the readings and declare a process nature had priced at 125 years paid off in full, with no rule book to check the math against. Hold that thought, because it changes how you see this dam. Everyone reads Hoover as a monument to concrete, mass, permanence, brute scale. But what actually made it buildable is invisible. A dead refrigeration system, hundreds of miles of quiet pipe threaded through the dark interior, holding the shape of the winter they manufactured in a desert. A machine that ran once, won its race against a century, and was sealed inside its own victory. So, that's sign-off. If it had been yours, the water still moving, the schedule waiting, what evidence would have been enough for you to shut it off? Tell me in the comments, and I'll see you on the next MegaBuilt.